About the native Linux KVM tool. Firstly, I'm going to talk about what is it. Then I'm going to talk a brief history of this project and who is developing it. Then I will walk through the features we already have and the features we may have in the future. After that, I'm going to show you how to use it and some demos, finally the Q&A. Native Linux KVM tool is a clean, from scratch, and lightweight KVM host tool implementation. It is about 15,000 lines of clean code. It is from scratch and lightweight. It's also a great learning tool for people who are interested in virtualization. And we want to integrate more tightly with kernel source tree. We care about both desktop and server users. For example, for usability, we want to have as little configuration as possible. For performance, we have a multi-threaded and paravirtualized device model. This project is very young. We're only 1 year and 5 months old. It is still under heavy development. Despite that, we already have some cool features. We can boot up to 254 with CPUs per VM. We have minimal legacy device emulation. We rely heavily on virtual devices. We have disk, network, serial, mouse, keyboard, real-time clock, VISA, SDO, and VNC support. What's more, we are planning to add more features and improve usability and performance. All started back to last March by a very, very long thread. We have Ingo, Avi, Alex, and Anthony, and Pekka had a very, very long thread named Unify KVM kernel space and user space code into a single project. 5 days later, Pekka launched this project with his initial commit with 3 files, 93 lines of code. About 1 year later, on April Fool's Day, we announced this project at the Linux kernel mail list. 2 months later, we had our second version of announcement. On July 25th this year, we had our first pull request for mainline kernel. Currently, we are targeting next merge window. We are having 17 developers. The number behind the name are the commits of the corresponding developers. We have Pekka, the creator of this project, Sasha, me, and Creel, and other developers. And I'd like to take this opportunity to thank Avi for his KVM internal and Ingo for his all-around support and encouragement. We have a mail list as suggested by Avi. We are sharing a same mail list as KVM project. And you can find us at the PVM channel at Freenode. And here below is the repository for project. So we have a mail list, we have an IRC channel, and a Git repository. We need you. Patches and ideas are more than welcome. What features do we have? We have a very similar command line interface like Git and Perf. You can boot a Linux guest into serial console or virtual console. If you prefer GUI interface, we have SDO and VNC for you. We also support SMP. We can boot up to 254 with CPUs. In fact, it is Sasha, a developer of our project, who raised the limit by his patch with the hard with CPU count limit. In order to support SMP, we implemented the multi-processor table specification. It's way easier than ACPI specification, and we just implemented the minimal needed for SMP. Disk support is one of the most important features of any hypervisor. So of course, we have disk support. We support raw disk images and QCOW2 disk images. It's now experimental, so we deliberately make them read-only right now. We also support raw block devices. You can pass a host partition to a guest directly. And we have another cool feature. We can boot a directory as a root file system for guest. Network support. There are two modes in network. One is the tap mode, and the other one is UIP mode. In tap mode, one has to do network address translation or bridge to allow the guest to access the outside of the world. The tap mode requires special privilege and some plane setup, which is a plane for some users. So that's why we implemented the UIP mode. In UIP mode, there is no special privilege needed. And it's from scratch and no ancient SLIP code. In QEMU, SLIP code, it's about 11.7 kilolines of code. And in our implementation, it's only about 1.5 kilolines of code. We have ARP, ICMP, IP, TCP UDP, and DHCP support. And in theory, any up-layer protocols above UDP and TCP can work, such as HTTP, FTP, SSH, and DNS. We have a built-in DHCP server, and no setup is needed in host side. That makes the zero configuration network happen. We have a UDP thread for all UDP traffics and a thread for per TCP connection. For performance, experiment shows that the UIP almost achieve the same as TCP UDP performance in host. Okay?
I'm just curious. So does UIP also do port forwarding? Can you actually get back into the guest from the host, or is it just?
Okay, I see. Not yet.
Okay.
It's always pretty simple to start out with less code because you just have less features. So why is UIP going to stay smaller than Slurp? So what was the reason for rewriting something from scratch? Are you never going to add any new features to it such that it'll always stay small? I mean, what's the rationale? Is it just that you use other people's code? Or?
Okay. Actually, I first looked at the QEMU's SLIP code. As a result, I feel I cannot port that to KVM tools, so I write it from scratch. That's very simple.
Okay.
We have two types of devices. We have virtual device and next devices. We have device emulation infrastructures. We are using KVM Exit and KVM L Event FD to support PL and memory mapped IO. We are using KVM LQ9 to support interrupt. We implemented a very similar PCI controller. The configuration space is emulated by handling the magical L port, CF8 and CF6. The number 1AF4 is used as the event ID, and the number 100 to 109 are used as device ID. And 1 to 9 are used as the subsystem ID. For bar address 0, it's an IO space, and it is used as the virtual configuration. This picture here shows the guest notifies us either through KVM exit or our event FD when the guest has block request. The block device, virtual block to IO, dispatches all the requests to jobs by calling the disk image read, write, flash to handle a request. After a request is done, it uses this to trigger an interrupt.
Wait, so you always trigger an interrupt for every request?
That's just for the pictures.
Oh.
We have some
That's called
speed up, yes.
They don't do parallel requests though,
So there's no parallel requests?
Actually, this is actually suggested by Anthony, right? To parallel, yes.
So it's not there yet, but it will be parallel.
In reality.
It's better for the wall, but not for QCal, right? So the QCal is still synchronous?
Yeah, okay. We have 4 backends. We have raw block device and raw disk image, QCal, and the QCal2 image as the backend.
Question.
Okay.
Why do you support QCal 1?
Why?
Yeah.
Because it's simpler than QCal2. We just implemented the first one and then the complicated one. That's why. Similarly, this is the data path for virtual net. The guest notifies us when it has something to transfer or it had a new buffer for incoming receive. And it notifies us for TX queue. The TX thread handles the request by calling tap ops TX or UIP ops TX, depending on we are in tap mode or UIP mode. The very similar for the RX queue. Virtual IP is another interesting feature. Firstly, NIP stands for Plan9 File System Protocol. It can use named pipe and TCP connection, file descriptor, RDMA channel, or virtual to use as its transport. We are currently using virtual as its transport, so no network setup is needed. We can use virtual IP to share files between host and guest very easily in 2 steps. Firstly, just using the -IP to specify a directory to share, and then mount it in the guest. More interestingly, we can boot a directory as a root file system using IP. I'm going to show you some demo later. We also have some other virtual devices, like virtual console for guest console, virtual RNG to help the guest to get some random numbers in guest. And we also have a virtual balloon device to increase or decrease the guest physical memory size. We have a serial device as the next device to support guest console and PS2 keyboard, mouse, and with the device to support SDN and VNC. And we have a real-time clock for guest timing. We have a very, very tiny and lightweight BIOS layer, so we can boot Linux guest without external BIOS dependencies. The BIOS just set up the E820 memory maps and sets up a real mode interrupt vector table and multi-processor table. So in the future, we want to have a vHostNet or block support and add a MacVTAP model in the network code. And we are also interested in the virtual SCSI, SCSI-based SCSI HBA, and I/O bandwidth limits. We want to add more disk image format support like VMDK and VDI. We are also interested in the IP plus overlay file system for QCOW file system layer for the guest. And we want to boot disk images without external kernel images and grab support and external BIOS support like CBIOS. And we also want to, we want to support non-Linux OS support and add a QLX paravirtualized graphic card. And we want to integrate with perf for profiling and tracing and GDB for debugging. And we may support now migration and live virtual support. Here are some commands we support. You can use KVM run to run a guest, stop to stop a guest, and pause, resume. You can use KVM list to list all the VMs you have started, and KVM Boolean for Boolean, and KVM debug to debug a guest, and KVM help and version. Here are some details. We have that -- name, CPUs, memory, disk, Boolean, VNC, SDO, RNG, IP, console, and device. And here is the kernel options, kernel inter-RD parameters for kernel command line, and some network options, and BIOS option, and debug options. Here is the KVM debug. It can dump the registers of a hanged guest. We have registers, segment registers, epic, and interrupt bitmap, and so on. Next, I'm going to show you some demos. Firstly, I'm gonna boot with a SDL. Okay, let's boot it. Okay. Next, I'm gonna start GDM. So here we go. We have DOM. Next, I'm gonna boot with a VNC.
What was the first boot?
SDL.
SDL. This one is VNC. And WinCViewer for it. Here we go. Login. Start GDM. Here we go.
Move the mouse.
Uh-huh.
Make the guest mouse.
Actually, we have some bugs right now. So I'm gonna demo it.
You might want to try KVM, the VNC server works a little better there.
Yeah. We really do not like the VNC server, actually.
Can you share the command?
Sorry?
The command.
You want to try it again?
Just cat the file.
Okay. Here it is. We have --VNC to enable VNC. Okay. Next. Sorry. I'm gonna boot into a serial console. And here we go, the serial console. Next, I'm gonna boot into a virtual console. Here we go. Okay. Virtual console. Next, I'm gonna show you how to use a directory to as a root file system. Here we have a root file system hierarchy in this directory, root file system. And I'm gonna boot into it. Here we go. And I'm going to show you how to share a directory between the guest and the host. This is the directory I want to share. Next, I'm going to mount it. Here we go. Yeah. Finally, I'm gonna boot with 64 CPUs. Yes. Okay, we have 64 CPUs. Okay, thank you guys.